Welcome to Ask and Learn.
We want to discuss the asymptotic behavior of f of x is equal to x to the fourth plus 1 over x, the same manner that we did in exercise 74. And then we want to use this to help us sketch the graph. So in 74, they give us what they believe the asymptotic behavior should be. In this one, we need to figure out what we think it might be. So if we were to first divide x into x over 4 and 1, we would end up with x cubed plus 1 over x. Now, if you look at this, well, we know that x cubed is going to tend to plus or minus infinity, and we know that 1 over x is going to tend to 0 as x goes to plus or minus infinity. So as x goes to plus or minus infinity. So essentially, for very large values, this 1 over x doesn't really matter, and this x cubed is the thing that truly matters. So what we want to show is that the limit as x approaches plus or minus infinity of x cubed, or not x cubed, but x to the fourth plus 1 over x minus x cubed is equal to 0. So we want to just show this, because if this is the case, then we know that the end behavior for our function f of x really is x cubed. So let's go ahead and start with that. So let's just simplify the inside first. So I'll go ahead and do that up here. So we have x to the fourth plus 1 over x minus x cubed. Now we need to get a common denominator, so let's multiply x cubed top and bottom by x. Simplifying this down, this is going to give us x to the fourth plus 1 minus x to the fourth all over x. And well, now those x to the fourth cancel out, and we'd just be left with 1 over x. So all we need to do is show that now the limit as x approaches infinity of 1 over x is equal to 0. Well, that's essentially what we said here at the very start, so that's 0. And then likewise, as x approaches negative infinity of 1 over x, well, that would also be 0. So we've shown that this here simplifies down to one of these cases, and both of the limits end up giving us 0. So we know the end behavior of this function, x to the fourth plus 1 over x, should be very close to x cubed. All right, now that we have that information, let's just go ahead and find our intercepts and our vertical asymptotes. So we know that our x-intercepts deal with up here, so this is the x-intercept, so we set that equal to 0, so we'd have x to the fourth plus 1 is equal to 0. Subtract 1 over, we get x to the fourth is equal to negative 1. Take the fourth root on each side, so we get plus or minus the fourth root of negative 1, but this here is an imaginary number since we're taking an even root of a negative number, so that means we have no x-intercepts. And then to find our horizontal asymptotes, remember, or not horizontal but vertical, our vertical asymptotes deals with setting the denominator equal to 0, so we're going to do x is equal to 0, so that seems pretty straightforward, nothing to really solve for. All right, now let's use this information for the next part. So let's just write down right now, all we know is that we have a vertical asymptote at x is equal to 0, and we have no x-intercepts. So let's go ahead and put down our dotted line for our vertical asymptote here. So this is at x is equal to 0. And now what we are going to have to do is determine what side of this we need to start. So we need to look at, so we had x to the fourth plus 1 over x. So let's look at the limit of this as we approach 0 from the right. So the limit as x approaches 0 from the right. So we're going to have 0 from the right to the fourth power plus 1 over 0 from the right. Well, if we raise anything that's slightly positive, which means coming from the right, to an even power, that should still be positive. So we're going to have 0 from the right plus 1 over 0 from the right, and then adding something slightly to the right of 1, of 0 and 1, well, that should still give us something positive, and then dividing that by something positive gives us infinity. So we know that the right-hand side of this will look something kind of like this. So it's going to start coming from positive infinity, and now this is when we use the fact that we know this has asymptotic behavior like x cubed. So it's going to have to rebound up and then start to follow this green line up to positive infinity. And then we could do the same thing to find the limit as x approaches 0 from the left, or we can use the fact that this is like 1 over x, and we know that 1 over x has opposite in behavior. So that means we're going to have to start from negative infinity over here, and then we're going to just keep on going up. There's no x-intercepts or anything, so then it's just going to have to turn around and then start following this green line like that. So this is a nice way for us to go about getting a sketch of the graph without doing everything that we've done in this chapter so far.